Ananya, how was your paper? Yesterday's paper?
So it was good.
Acha. How much you are getting now this time?
That they'll tell us today at 3 o'clock. The results will be out at 3 today.
Oh, that's okay, but mostly when we write, we come to know tentative.
Uh,
More than 120 it will be?
I think so.
Okay, fine. Sum number 23. In Young's double slit experiment, two slits are 0.3 millimeter apart. The distance between the screen and slit means capital D 1 meter. It is observed that fourth bright is at 6 millimeter. So distance of fourth bright is at 6 millimeter from central bright. What is wavelength of light used? This is the question. Now we know distance of nth bright from center is given by n lambda d by d. So fourth bright will be 4 lambda d by d. Therefore, lambda is x4 into d upon 4d. x4 is 6 into 10 raised to minus 3. 0.3 is 3 into 10 raised to minus 4 in meter upon 4 capital D is 1. So 6 3s are 18 upon 4 into 10 raised to minus 7. 4 4s are 16. 4.5 into 10 raised to minus 7 meter or 4,500 angstrom unit. 4,500 angstrom unit. Check the option where it is given. 4,500 option D. And this Sunday, which test, Ananya?
So we have oscillation, circular motion, projectile, rotational motion, magnetic effect on electric current, electrostatics, only capacitor part, polarization, and interference and diffraction.
That means this time all syllabus we have now.
Yes, sir.
Okay. So your target should be 160.
Yes, sir.
Mhm.
Done, sir.
Okay. 20. Try 24th, one sec, wait, huh? Hello? Yes. Now, next sum. Two slits separated by, got the answer? 0.975 millimeter. In two slit experiment, two slits are separated by, slits means small d are separated by 1 millimeter, illuminated with red light of 6.5 into 10 raised to minus 7 meter. The interference fringes are observed on the screen, which is 1 meter away from the slit. The distance between third bright and fifth dark. Third bright and fifth dark. Dark I am putting dash, bright I have written just number. On the same side is equal. Very important is meaning of same side. If this is screen, this is central bright point. First, second, third, here we get third bright. First dark, second dark, third dark, fourth dark. This is fifth dark. Now both are on same side, third bright and fifth dark. What is distance between them? Some or difference from the center?
Difference.
Difference, correct. So I know formula for nth bright, I know formula for nth dark. So distance between third bright and fifth dark, comma x5 dash minus x3 is 2 into 5 minus 1 lambda by 2 d by d, odd multiple of half the wavelength, minus 3 lambda d by d. So we get this is equals to 2 5 is 10 minus 1 9 lambda by 2 d by d minus 3 lambda d by d. So this will become 2 into 3 6 9 minus 6 3 by 2 3 6 minus 3 upon 2 lambda d by d. So 3 into lambda is 6.5 into 10 raised to minus 7. Capital D is 1 and small d is 2 into 10 raised to minus 3. So 2 will get cancelled. So we get 3 5s are 15, 3 6 are 19, 19.5 into 10 raised to minus 4 meter. Minus 7 and minus 3, that is minus 4, correct. So 19.5, something I did wrong. 19.5, 10 raised to minus 1 millimeter. 1.95. Hello?
Yes, sir.
Yes, sir.
1.5 बराबर है ना 1.95 है क्या 1.95 मिलीमीटर ऑप्शन है
Hi.
वही आंसर है 1.95 में 1.95
Sir, I got
oh no
0.95.
yes correct I cancelled this one, it is not 2, this I cancelled, sorry this is 1 huh? So it will be 19.5 upon 2, 0.975.
Sir, done.
Okay, sum number 25. In Young's double slit experiment, using source of light of wavelength 5000 angstrom unit, the fringe width is 0.6 millimeter. If the distance between screen and slit, capital D, is reduced to half, so D2 becomes half of original, then what should be the wavelength of light used? in order to get fringe width of 0.4 millimeter. So lambda 1 x1 lambda 2 x2. So fringe width is lambda d by d. So x1 upon x2 is equals to d lambda 1 upon lambda 2 d2 upon d1. So 0.6 upon 0.4 equals to 5000 upon lambda 2 we want. D2 is half of D1 upon D1. 2 2s are 4, 2 3s are 6. Therefore, lambda 2 equals to 5000 upon 6 in Armstrong unit. So that will become 2 into 3, 2 into 3, 2500. फर्स्ट वाला कितना दिया है फर्स्ट वेवलेंथ is 5000 split width is reduced to half 0.6 0.4 2 2s are 4 2 3s are 6 this will become 2 into 3 6 lambda 2 अरे फिर से तो देखो मिस्टेक कर दिया
It will be D1 upon D2, right?
yes yeah first mistake first of all this is d1 upon d2 so it will become d1 upon half d1 this will get cancelled d1. So, lambda 2 is 10,000 into 2 upon 3. So I can write 2 by 3 into 10 raised to 4 in Armstrong. That is nothing but 20 into 10 raised to 3 into 10 raised to minus 8 to convert in centimeter. So it will become 6.666 into 10 raised to minus 5. Now check. 6.66 into 10 raised to minus 5 or 66.6 into 10 raised to minus 6 in centimeter. Option. Done?
Yes, sir.
Yes, sir.
26th. Light of wavelength 6000 Armstrong unit is passed through two pinhole 0.5 millimeter apart. An interference is formed on the screen kept parallel to the plane and 50 centimeter from the them. Distance between second and fifth bright on same side. Same side means minus. Distance between second and fifth bright, comma x5 minus x2 will be 5 lambda d by d minus 2 lambda d by d. that will be 3 lambda d by d. So 3 into lambda 6 into 10 raised to minus 7. Capital D is 50 into 10 raised to minus 2 meter, and small d is 5 into 10 raised to minus 4. 5 into 10, 50. 3 6 18 into minus 2 and plus 1 is minus 1. Minus 1 and minus 7, minus 8. Minus 8 plus 4 will become minus 4 in meter. Or it can be 18 into 10 raised to minus 1 millimeter, 1.8 millimeter. 1.8 millimeter, option C.
Done.
Okay. In Young's double slit experiment, on the screen, the fifth bright band due to one monochromatic light. In Young's double slit experiment, on the screen, the fifth bright band due to one monochromatic light. Fifth bright due to one monochromatic light of wavelength lambda coincides with 6 bright due to another. Then what is lambda 1 upon lambda 2 if d and small d and capital D are same? Now see meaning. If this is screen, fifth bright due to one wavelength. Fifth bright due to one wavelength coincides with sixth bright due to other wavelength. Now coincide means point will be same. If this is S2, this is S1, there are waves starting at this point. So when you use lambda of wavelength lambda 1, then at this point fifth bright comes and other one ka sixth bright. So whenever word coincide comes, that means this distance are same. Okay.
Yes, sir.
So when coincides, then distances are same. When coincides, then distances are same. That means distance of fifth bright due to first is sixth bright due to second. What is formula for fifth bright? 5 lambda 1 d by d. 6 dark bright, 6 lambda 2 d by d. Cancel. So lambda 1 upon lambda 2 is 6 upon 5. Oh, this answer 6 is to 5. C option.
Done.
Okay. 28. Everybody has done?
Yes, sir.
Yes, sir.
28. In double slit experiment, interference pattern is obtained in such a way that angular width, angular fringe width is 1 degree. Now meaning, if this is screen and this is fringe width, angle subtended by fringe width at slit is called as an angular fringe width. So a capital D, a x, and this theta is angular fringe width. So from this figure, I can say angular fringe width denoted by theta, tan theta is same as theta for smaller angle, is x by d, but theta should be in radian. So 1 degree is 1 into pi by 180 radian equal to x by d. What is given? Wavelength 6000. Okay, and separation between slit we want. So this is pi upon 180. Fringe width is lambda d by d upon d. So d equals to 180 lambda upon pi. Therefore it is 180 lambda. We have to calculate. नहीं दिया है ना lambda 6000. 6 into 10 raised to minus 7 upon pi. Pi you can take roughly 3. So 3 to the 6. So 360 के आसपास में option in meter. that is 360 into 10 raised to minus 4 in millimeter, which will be equals to minus 4, 3.60 into 10 raised to minus 2 millimeter. So 3.43 into 10 raised to minus 3, that is option C.
Done, sir.
Okay, 29. The correct curve between fringe width distance between the slit ds. Fringe width and distance. Fringe width is lambda d by d. So fringe width is inversely proportional to slit width. Whenever inversely proportional comes, this is the nature of graph, like Boyle's law wala. So that is given in B. Inversely proportional means like product is constant. So Boyle's law, PV is constant wala graph, also called as isotherm. Either rectangular hyperbola bolte hain इसको. Done na?
Yes, sir.
30th. In double slit experiment, we get 10 fringe. We get 10 fringe in the field of view of a monochromatic light of wavelength 4000. Yeah. अच्छा नहीं आपका रेट ज्यादा है ना 8.75 के ऊपर है ना नहीं 8.75 के ऊपर मैं नहीं दूंगा क्योंकि मुझे एक्सिस बैंक दे रहा है ठीक है so lambda 1 is 4000 if we use monochromatic light of wavelength 5000 angstrom unit then the number of fringes obtained in the same field of view will be how much मतलब same space में earlier we could see 10 fringe for wavelength lambda 1 then how many fringes we can see number of fringe with this wavelength different wavelength what will change fringe width will change or it will remain constant fringe width is lambda d by d so if wavelength is changing what about fringe width will change or it
Change.
Change.
that means total distance I have same fringe can become less or more so in first case if n1 fringe is formed and one fringe ka width is n1 x1 then total fringe width will be n1 x1 second will be n2 x2 this line clear one fringe is x1 so two fringe is 2x1 n1 fringe is n1 x1 second wale ka fringe width x2 n2 ka n2 x2 I hope you all followed
Yes, sir.
n1 is given 10 this is lambda 1 d by d n2 lambda 2 d by d cancel therefore 10 into 4000 equals to n2 we have to calculate lambda 2 is 5000 1 2 3 1 2 3 cancel so 40 equals to 5 and 2 and 2 equals to 8 8 fringes are formed in same field of view that is A option
Sir, can you repeat the N1 X1 वाला part?
See, I said कि एक space है. In that I want to see the fringes. एक fringe दिखा तो fringe width के distance होगा ना.
हाँ.
दो दिखा तो 2 times fringe width. तीन दिखा तो 3 times. ऐसा N1 दिखा तो N1 times.
Okay.
Next वाला same distance. लेकिन fringe width अलग. तो नंबर भी अलग होएगा.
Yes sir.
तो बोल दिया N2 X2 हो गया सपोज.
Okay.
बट फर्स्ट का जगह और सेकंड के लिए स्पेस सेम है. तो N1 X1 शुड बी N2 X2.
Yes sir. Got it.
इंपॉर्टेंट है ये सब थोड़ा. राइट इट नाउ.
Done, sir.
Sum number 31. With a monochromatic light, fringe width obtained in double slit experiment is fringe width is 0.133 centimeter. The whole setup is immersed in water whose refractive index is 1.3, and new fringe width will be how much? New fringe width will be how much? First system was in air, then it is immersed in water. What will be new fringe width? What is formula for fringe width? Lambda 1, lambda d by d, na?
Yes, sir.
Yes.
So when you take the system from air to water, can distance between source change?
No.
No.
Sorry sir.
Can distance between source change when you take the system from one to another?
No.
No. Distance between sources will change? No. खाली wavelength जो medium पे depend होता है, that will change, ना?
हाँ.
So can I say first fringe width upon second fringe width is first fringe width wavelength in air, then second wavelength in water?
Yes sir.
What is this ratio called as? Refractive index. हो गया अभी काम. Therefore x2 is x1 upon refractive index. So it will be 0.133 upon 1.33. So it becomes, I'm just removing the decimal, into 10 raised to 0.133 decimal nikala, 123, 10 raised to minus 3 upon 133 into 10 raised to minus 2. That will become 10 raised to minus 1 meter or 0.1 centimeter. पॉइंट वन है क्या, देखो जरा.
Option B.
है, ऑप्शन बी है.
हाँ.
Sum number 31. Yes, option B. Option B, D ना. ऑप्शन बी है, बी.
Done, sir.
25th, what answer we got? 25th?
(66.6 into 10⁻⁻6). That's D.
अच्छा से 24 से बताना. 24th का B ना?
Hmm.
And 25th का?
D.
25th का D. D for
Hmm.
Delhi. And 26th?
1.
1.8 millimeter C.
C. और 27th का B ना?
C.
C. 6/5.
6/5 है उसको.
Hmm.
Fifth bright band of lambda 1 coincides with this. 6/5. C na?
Hmm.
Yes, sir.
28th also C.
Hmm.
29th B.
Hmm.
30 का A.
तो T का A, हाँ.
और 31 का भी किया वो B. बराबर?
Yes, sir.
ठीक है. 32. In double slit interference experiment, the distance between slits is 0.05 centimeter and screen is 2 meter away from the slit. Wavelength is 6000 Armstrong. The distance between the fringes is, so fringe width is lambda d by d, that is 6 into 10 raised to minus 7 into capital D 2 meter upon 5 into 10 raised to minus 2, ये सेंटीमीटर है, into मीटर के लिए minus 2 extra. So it will be 12 upon 5 into 10 raised to minus 3. That means 2.4 into 10 raised to minus 3 meter or 2.4 millimeter. 2.4 millimeter, which is same as 0.24 centimeter.
Centimeter.
A option.
That's it.
In Young's double slit experiment, बहुत important song. Distance between slit is 2 millimeters and illuminated with mixture of two wavelengths. One is 12,000 lambda 1, I'm giving the name. Second is lambda 2 10,000 Armstrong. At what minimum distance from the center? So distance means x from the center. On the screen, which is 2 meter away from the slit, will the bright fringe of one pattern coincide with bright fringe of other? So at what distance fringes will coincide? At what distance fringes will coincide? Wherever fringes coincide, distance must be same. So point,
Yes.
yeah, point where fringes will coincide, distance will be same. That means x. Abhi, how many fringes coincide? I don't know. Suppose n1 fringe of first one is a distance of n2 fringe of second. So n1 lambda 1 d by d is n2 lambda 2 d by n1 into 12,000 equals to n2 into 10,000. 1, 2, 3, 1, 2, 3. So 6 band of first color is coinciding with 5 band of second. So I can find 6 n1 का distance or I should find 5 n2 का. अभी n1 मतलब क्या? 6 times n1 is 5 times n2. So whenever you see product is same, think of LCM. LCM of 6 comma 5 is 30. So now n1 if it is 5 product will be 30 and n2 if it is 6 product will be 30. That means fifth bright of first color or sixth bright of second color are coinciding. So therefore distance of fifth bright of first color will be 5 lambda 1 d by d. You can take sixth of second, then also same answer. Lambda 1 is 12,000. So it is 12 into 10 raised to 3 in Armstrong into 10 raised to minus 10 to convert into meter upon small d 2 into 10 raised to minus 3. 12 5 is a 60. 5 lambda 1. Lambda 1 is 12. So 2 into 6 is 12. D2 कितना है? D कितना है? 2. एक मिनट, जगह नहीं इधर, into 2. I'm just removing this so that I can get proper space for calculation. You all have followed concept first?
Yes, sir.
Because
Yes.
who is coinciding they have not given. But we know when coinciding then distance is same. So from that we checked the number. So we got fifth bright of first or sixth bright of second will coincide. Just copy till this then I'm doing.
Copied.
Done, sir.
Now find that distance then of fifth bright for first color.
6 mm.
6 millimeter?
Hmm.
Correct. So required distance equals to 5 lambda 1 d by d. 5 into 12,000 into 10 raised to 3 into 10 raised to minus 10. Capital D is 2 and small d is given as 2 millimeter. So 2 into 10 raised to minus 3. This will become 60 into 10 raised to minus 4 in meter, which is same as 6. 34th. Yeah, you all have done this part?
Yes, sir.
Yes, sir.
So just to done.
34. In Young's experiment, fringe width is 4 millimeter. Fringe width capital X 4 millimeter. The distance between third bright on one side and 11th on the other side. So it is x11 plus x3 because they are on other side. This much clear now? I didn't
Yes, sir.
subtract it because they are on other side.
Yes, yes.
Will be how much? 11 then 13. Abhi ekdam simple hai. X11 plus x3 will be 11 lambda d by d plus 3 lambda d by d. That is nothing but 14 lambda d by d. And lambda d by d is nothing but fringe width 4. So it becomes 56 millimeter.
Done, sir.
Yeah. What did you say? Done, Prisha?
Yes, sir. Done.
Okay, great. In Young's double slit experiment, interference pattern is obtained on the screen of light having wavelength of 6000 angstrom. Coming from coherent source at certain point P, third dark fringe is formed. Third dark X3 dash is formed. Then path difference as third dark. Path difference at third dark is question mark. What is path difference? X d by d, na? याद है
Yes, sir. Yes, sir.
path difference is x d by d. So path difference for nth dark x d by d is odd multiple of half the wavelength.
Yes, sir.
So for third it will be 2 into 3 minus 1 lambda by 2. That means 5 lambda by 2, 5 into 6 into 10 raised to minus 7 upon 2, 2 3 is 6, 15 into 10 raised to minus 7 meter. They want in micrometer, so 1.5 micrometer. 1.5 option B.
Done.
36. In a biprism, eyepiece is at distance of 1 meter from the source. The separation d between image of two coherent source obtained by biprism is 1 millimeter. Convex lens of focal length 20 centimeter is placed at distance of 40 from eyepiece. Eyepiece matlab screen. Convex lens is placed at 40 centimeter from that screen. To obtain diminished image on the focal plane of eyepiece, then separation d1 between these two images will be how much? To get diminished image. This distance is called as u, and screen se distance is called v, and this total is d. Is much clear?
Yes.
Because this is source and eyepiece is screen, distance between them is 1 meter. So can I say u plus v is 100 centimeter? So u plus 40 equal to 100, therefore u equal to 60 centimeter. Now d1 upon d is v upon u. Linear magnification वाला formula बताया था आप लोग. d1 we want, d is given 1 millimeter, v is 40 and u is 60, therefore it is 2 by 3. Ratio is millimeter because d1 millimeter, 0.67. Any doubt?
No, sir.
No, sir.
Okay, done.
Yes, sir.
Yes, sir.
37th now. In a biprism experiment, the distance between slit and eyepiece is 1 meter. And distance between two coherent sources is 0.5 millimeter. Wavelength of light used is 6000 angstrom unit. Distance of 10th bright from center. 10th bright from center, the easiest one. 10th bright distance is 10 lambda d by d. So 10 into 6 into 10 raised to minus 7, capital D is 1, small d is 0.5, so 5 into 10 raised to minus 4. That is 12 into 10 raised to minus 3 meter or 12 millimeter. 12 millimeter means how many centimeter? 1.2 centimeter. है ना? Hello?
Yes, sir.
1.2 centimeter.
Done, sir.
Next one. 38. In a biprism experiment, distance between slit and focal plane of eyepiece means capital D 50 centimeter. When convex lens is introduced between the biprism and eyepiece, distance between image will be 1.6 millimeter by putting convex lens and 3.6. So one is D1, other I can call D2. For two different position of lens, what is distance between virtual sources? Distance is root of d1 d2, if you remember theory. So
Yes, sir.
1.6 into 3.6, that is 16 into 36 into 10 raised to minus 2 in root, 4 into 6 into 10 raised to minus 1, that means it is 2.4 millimeter. 2.4 millimeter. Okay.
Done.
49. Done? Everybody is done?
Yes, sir.
In a biprism experiment, slit is illuminated by light of wavelength 5000. The number of bright fringes passing on the screen if path difference is changed by 0.05. Okay, मतलब ये point है, इधर दो source, तो ये point suppose I call P, then path difference at P will be S2P minus S1P. They're telling how many fringes will pass if path difference is changed by 0.05 centimeter. दूसरा point इधर आ गया Q. So one path difference is this. Second path difference at Q will be definitely S2Q and S1Q का difference. ये दोनों path differences changed by 0.005. Change in path difference is given as 0.005 centimeter. So at P, when path difference is S1P, S2P, suppose N1 band is formed and here N2 band is formed. Hello?
Yes, sir.
Path difference for N1 bright is N lambda d by d.
Yes.
X divided is n lambda for bright. Hello?
Yes, yes.
So for n1 bright, path difference is n1 lambda. For n2 lambda minus करो तो ये change in path difference आएगा. So I can say therefore n1 minus n2 into lambda, which is 5 into 10 raised to minus 7, is 5 into 10 raised to minus 5. So change in number of fringe will be 10 raised to minus 5 upon minus 7, that is 100. देख लो बराबर समझा आप लोग को ये?
हाँ
बहुत सही समय, नहीं समझा तो फिर से बताता हूँ. Path difference changes by some amount, then fringe will change by what? So if path difference is something, for nth bright, that something is n lambda. So I took first path difference minus second path difference is n1 lambda minus n2 lambda. Then n1 minus n2 you have to find kitna fringe mein difference. So that we got 100 fringes are passing by. Option C. Yes, Prisha followed?
Yes, sir.
Prisha, Ananya?
Yes, sir.
देख लो वापस देखो पाथ डिफरेंस राइट पॉइंट पे रहता है n लैम्डा, तो सपोज वो n1 लैम्डा है, दूसरे पॉइंट पे n2 लैम्डा, दोनों का फर्क मतलब चेंज इन पाथ डिफरेंस. सो n1 minus n2 लैम्डा इज चेंज इन पाथ डिफरेंस.
Done, sir.
Sum number 40 and 41 we are doing, then we'll stop. In a biprism experiment, distance between two parallel slit is 1 millimeter. Wavelength of light used is 6000 angstrom unit. And distance of the screen is 100 centimeter, that means 1 meter. The bandwidth is how much? So bandwidth is lambda d by d, that is 6 into 10 raised to minus 7 meter. Capital D is 1 meter, small d is 10 raised to minus 3. 6 into 10 raised to minus 4 meter, which is 6 into 10 raised to minus 1 millimeter. So it is 0.6 millimeter. 0.6 millimeter. Option C. Sum number 41 also check. In the above question, distance between first bright and 8th dark on same side. Same side means difference. So distance between कौन सा वाला बोला है? First bright and 8th dark. So x8 dash minus x1. That will be 2 into 8 minus 1 lambda by 2 d by d minus first bright will be 1 lambda d by d. 8 2s are 16 minus 1 15 lambda by 2 d by d minus 1 lambda d by d. 15 upon 2 minus 1 will become 15 minus 2 13. 15 minus 2. So 13 upon 2 lambda d by d. Clear na meaning?
Yes, sir.
What is lambda d by d called as fringe width?
हाँ
So ये 13 upon 2 fringe width मिला हम लोग को 0.6 from previous one. So therefore it is 3.9. 13 into 3, 3.9.
yes, sir.
Just complete this.
Completed.
So that's all for today. Next class, first I will explain you theory of diffraction, and then I will do remaining sums. So
Okay.
this week test for you all will be wave theory. Wave theory तो बीच में दे दूंगा, अश्लेषा आप लिख लेना. बाकी लोग के लिए interference है. Sunday test is interference in MCQ.
Okay, sir.
That's all for today. Next lecture Wednesday as usual. Tomorrow there is no class.
Thank you, sir.
Thank you.
Thank you, sir.
And for
Bye, sir. Thank you.
Prisha.
Yes, sir.
For you lecture is there tomorrow evening, huh? 8:30.
Tomorrow evening, 8:30.